For our homework this week, there are two Excel problems, both creating time series graphs and then doing some calculations. So for the first one, we need to create a time series graph of this annual revenue data for Nike. And then we will use the trendline option to choose the best fitting trendline, and then use the equation that results to forecast for the next 2 years. So I'm actually, in order to avoid giving you the answer, going to show you how to do this, but I'm going to choose the wrong choice for a trend line so that you can figure out the right one. Okay, so I've gone ahead and added 2 more years of data to this file, and then I don't want to be plugging in large values for X, because X will be my year and my revenue will be Y, and I'm trying to predict Y, or my revenue. So I rename these time periods so that my formula equations would be more manageable. So I'm going to go ahead and plot this. And I'm going to use a scatter plot, and I'm going to have it give me the line as well so that I can kind of see what's going on. And then to add a trend line, we right click on the data, add trend line. Okay, so I'm gonna, the first thing I need to do is display the equation on the chart and the r-squared value, because I'm going to use the r-squared information to see goodness of fit, and then I'm also going to look at what's happening with my trend lines, and then decide which one is best. So for example, I'm just going to go between linear and exponential, and you need to try all of these options and find the best one, but again, I don't want to give away the answer, so I am just going to pick from these. So my answer will possibly be wrong. Okay, so linear has a r-squared of 0.92. It looks like it's going to undershoot my predictions more and more over time. And exponential way overshoots. So even though, interestingly enough, the exponential fits really well early on, which is why you're getting this high r-squared. But if you see how quickly it's deviating from the data, I wouldn't use that. I would use this one if I had to choose between the two. So remember that r-squared isn't everything. You also need to look at what's happening with your data, and then also what might be happening in the future. Okay, so given that, if I were to use linear, I would need to plug in my x values into my equation, and my equation is literally right here. So I'm going to do equals 958.94 times x, which is my 35 right here, and I'm just going to use the cell so that I can drag this formula or copy paste it down and then have it calculate the next cell for me. And then minus 4794.2. Enter. Oh, it didn't like my. And then now I have my prediction, and you can see that it's low based on the trend here, which we expected when we looked at that. And then I'm going to copy paste it down for 36. So I want to know what my trends look like on here. So I'm actually going to expand my data, and now I can see where my two plots lie here. Okay, so that's how you would attack that problem. For the next problem, we're looking at carbon dioxide data, and we need to fit these three linear, exponential, and quadratic trends to that data, and then we're going to do some calculations to figure out which fit is best. So we're actually going to calculate the error between each method. Okay, so this is my data for the last problem, and once again, I need a time index because I don't want to use really large x values in my calculations. It just makes the equations really messy. I'm going to drag this down, and it will autofill all of my data. And then eventually I'm going to need to make some predictions. So I'm going to drag this down to 69. And then I'm going to make a formatting so I can see easily what I was doing. These are going to be my calculations and my predictions. Okay, so I need to do linear, I need to do exponential, and then a polynomial to the order of 2. So first thing I'm going to do is just make 3 graphs. And I'm going to make one graph, get it the way I like it, and then I'm going to leave it. So I don't like that this starts at 0. It's really hard for me to see the trend, so I'm going to start it at 300. So I'm going to format this axis, and I'm going to set the minimum to 300. Okay, that's better. Now I can see what's going on with the data a little bit better. So I need 3 of these, so I'm going to copy. Let's do that. I'm going to click my graph. I'm going to copy, and then I'm going to click out of the graph, and I'm going to paste it. So I have the same graph. And then I'm going to paste one more time, Control V. Okay, so now I have 3 graphs. Oops, I meant to put them up higher. Let's put this one up here. Okay, so then I'll be able to add my 3 trend lines, each separate. In order to explore which one is performing better, we have our linear, and then we have exponential, quadratic. So I'm going to do some calculations in here later, and I'm going to need to calculate some errors. So the errors I need to calculate are my linear absolute error. I'll need my exponential absolute error and my quadratic absolute error. I'm going to make these a little bit bigger so I can see. Okay, so first I need my equations, then I can calculate the errors. So let's do linear first. Right-click on the data, add trend line, linear, display the equation and the r-squared on the chart. Move that up, and I'm good. Now I need to do exponential, so right-click, add trend line. I'm going to choose exponential this time, and display the equation and the r-squared on the chart. And then I'm going to move this up so I can see it. And then finally, I'm going to right-click on this data, add trend line, and then we're going to do a polynomial with the order of 2. And I need my equation and my r-squared. Okay, so what I want to know is what is the average absolute error for all of these. So in order to calculate that, I need to do the same thing I did in the previous problem, where but this time I'm taking the difference between the actual value, which is right here in cell C2, minus the predicted value. So to do that, I only want the absolute error, meaning I don't care if it's positive or negative. I just want the value itself. So I'm going to use the absolute function. And then for the linear equation, we're going to take the actual value minus, and then I'm going to do my equation here. So 1.5511 times x plus 306.92. I'm going to close out my parentheses, and then I'm going to hit enter, and now I have my prediction. I'm going to double check it really quickly. So I have my actual value. Oh, I did something wrong. I clicked the wrong cell. I want my x value, my time index, not my CO2 value. So let's correct that. That would have been a very large error otherwise. So my actual value minus my predicted value, which is 1.5511 times x, which is time index 1 for this row, plus 306.92. Enter. Okay, that's much more reasonable. Always check your work, because sometimes when you're working quickly or trying to talk and work, you can make mistakes. I'm going to just drag this all the way down. And I'm actually going to drag it, yeah, we'll just drag it down here actually. And then I need to do the same thing, but now for the exponential formula. So my exponential formula is right here. So absolute function, my actual value minus my predicted value, which is 309.19 times e to the 0.0044 times x, which is 1, close my parentheses, and now I have my error for this one, which looks what I would expect. It doesn't look outrageous, so I'm going to drag this cell down. I'm going to leave the quadratic to you to calculate using the same process with this quadratic formula down here. Okay, I've gone ahead and calculated my absolute errors for quadratic, and I can already see they're a lot smaller, so or they seem to be at least, so I'm interested in seeing the results. So then the only thing left to do is take the average for each of our errors. So for linear, we'll take the average of that data. For exponential, we'll take the average of our exponential errors. And I'm going to just drag this formula over and get my average for the quadratic. So then from here you can write up what you've noticed and finish answering the question. And then you'll need to use the best fitting equation to make your predictions down here. And one tip for that is that you can enter a formula, and we did our prediction right here. So if it were me, I would just copy paste from the best fitting equation. So in this case, the quadratic, which I'm not showing you because I want you to do it yourself, but I would copy and paste that and then come down here in the cell and then equals and then control paste, and then I would just fix the make sure that it's, x is referencing B60. So that's one way to do it, or you can just type it out again. So it's up to you, but when we do that, we get our predictions for the next 10 periods, and then we could create a new graph